Okay, so we go to the next topic, absolute convergence, converge conditionally, and diverges. So if a series of an with the absolute value is converges, then the series an converges and said to be converge absolutely. If the series an with the absolute value diverges, but the series an converges, then an is said to be converge conditionally. Okay, so we go to the first example when we have a series of negative 1 to the power of n multiply with the 9n over 9n plus 1 multiplied by n square. So when we put the absolute value and cancel the 9n, we get the 1 over 9n square. So firstly, we have to test for the alternating series test, where here we find that an is a 1 over 9n square, an plus 1 is the 1 over 9n plus 1 square. So we substitute the value one by one and we compare the series, and we identify that an was greater than an plus 1. And then we do the second test AST, where the limit n approach infinity, 1 over 9n square is equal to 0, which show that by AST this series is converges. Okay, so by using the modulus, we get the value of the absolute value an with the value of 1 over n square, where by using the p series, the power is equal to 2, which is greater than 1, so this series is converges. So since this series converges, the previous the series that we test by the alternating series was also converges. So this series said to be converge absolutely. Okay, so we go to the next example where we have a series of negative 1 to the power of k over square root k. So by letting or put the absolute value, we get the value of a series k equal to 1 until infinity, 1 over square root k. So first we test for the AST, ak is equal to 1 over square root k. Ak plus 1 is 1 over square root k plus 1. We substitute the value for each 1 by 1, 2 and 3 value, and then we compare the value, where we get ak was greater than ak plus 1 because 1 is greater than 1 over square root 2. In here, we test for the second condition of AST, limit k approach infinity, 1 over square root k, and we get a 0. So since it was satisfy both conditions, so an is convergent or converges. And then we test for the an. Here we have to identify either there was a p series, geometric series, or if there was many polynomial, we can use the limit comparison test. But for here, we can test by using the p series. The p is equal to half, which is less than 1. So the absolute value of an is diverges. So since the absolute value of an diverges, an converges. So the question of the series negative 1 to the power of k divided by square root k is converge conditionally.